Alright, this is take 2 of our video. The first one was an epic fail. We're going to try this again. I'm Kevin Thompson. This is Taylor Horton filming.
Hey guys.
We're going to talk a little bit about different types of trusses. Namely, here on the left, we're going to start with is the Howe truss. It's a truss mostly used in bridges and things like this. On the right, we have the hip truss, which is largely a roofing truss designed to hold loads from the top. Okay, moving right along. We're now going to get into definitions of compression and tension. The handy-dandy interweb has told me that compression is the result of subjection of a material or structure to compressive stress, which results in reduction of volume as well as compared to an uncompressed but otherwise identical state. All that to say, this is what happens when you push down on top of something, right? Yeah. Okay, so it's the opposite of tension, which is the pulling force exerted by a string, cable, chain, anything like that on a similar solid object on another object. So it's pulling forces. Okay, that's big fancy definitions for very simple things. Okay, what's next? Let's see.
Should we show them the
we're gonna look at the digital model now. To kind of show you how these trusses work just a little bit better in a way that shows it a little more three-dimensionally and clearly. Okay, here we go. Here's our trusses right here. Circling the ones on the left with the mouse there, those are the hip trusses, and the Howe trusses on the right. I'm going to turn on a layer of the model now that shows you a surface over the layers, or a surface over the truss where the loads would be supported here. So you can see here that this is where loads would be held, also on the opposite side of this for a roof truss, and these bridge trusses do a lot better with tension forces on the lower side while they're using bridges oftentimes.
So now we're going to talk about the compression and tension members in each truss. So for the Howe truss, the tension members would be the slanted members, the diagonal members here, and I believe there's 8 of them, and whether or not how much tension you have on each one depends on whether the load, wherever it is placed on the truss. And for the hip truss, it would be also the diagonal members for the roof system that would be on top. And the compression is, of course, the vertical members in the hip truss, and as well as the same in the Howe truss.
Okay, now we're moving right along. We figured that the best way we can kind of begin to talk about tension and compression is to test these things, right? So the best way to test anything is to test it until failure. So we're going to back up now. We're going to start stacking things on this. We're really proud of how strong this truss is, by the way. So we're just going to start stacking things on it now, and when it collapses, you'll know that the compression forces were just too much for it, right? That's when you'll kind of know its maximum amount. For the sake of anticipation, we're going to stack the smaller things first.
So this is 2 books.
2 books. 3 books. There it goes. There it goes. It's down. It's
Good.
down.
Thank you guys for your time.